Today, we're going to dig into the incredible, almost invisible engineering that's happening right underneath our feet. We're following the hidden journey of a pipeline to uncover the really clever solutions that, keep our world running. I mean, seriously, have you ever been walking down the street and just wondered what kind of complex network is buzzing with activity just a few feet below you? It's this whole hidden world, and today, we're exploring a huge piece of it, the secret life of a pipeline. So at first glance, this just looks like a normal road, right? You got the center line, the ground level, but look deeper. Running silently right underneath everything is the carrier pipe. This is our hero for today, a vital artery carrying resources over huge distances, completely out of sight. Okay, so our pipeline's journey isn't just through empty fields, not at all. It has to navigate the world that we've built right on top of it. And its first big challenge, getting across the very roads we drive on and the railways that connect our towns and cities. Just think about it for a second. You can't just, dig a big trench across a busy highway or a major rail line. The constant weight, the vibration from traffic, that would be a total disaster just waiting to happen. So, this gave engineers a really critical problem to solve. How do you protect this essential pipeline without messing up the world above? And this diagram shows the solution perfectly. It's so smart. Instead of putting the carrier pipe directly in the ground, engineers first install a bigger, tougher pipe called a casing pipe. It basically acts like a personal protective tunnel. The carrier pipe just slides right through it, completely shielded from all that stress and weight. Oh, and see those vent pipes on the ends? That's another clever safety feature. It lets any potential leaks escape to the surface where they can be detected. So a good way to think of it is that the casing pipe is a pipe for the pipe. It's really a brilliant piece of sacrificial engineering. It takes all the hits, all the pressure, leaving the important carrier pipe inside totally safe and sound. And, big bonus, if that carrier pipe ever needs to be fixed, you can potentially replace it without having to dig up the whole road. And this isn't just guesswork. Engineers have this down to a science. This table shows the exact calculations they use. So, depending on how big the carrier pipe is, they know precisely how large that protective casing needs to be. For a small 3-inch pipe, you need a casing that's just 2 inches wider. But for a massive 30-inch pipe, you need a full 6 extra inches of space. It's all about making sure there's exactly the right amount of protection. And yep, you guessed it, this exact same idea applies to railways. The load and the vibrations from a train are just immense, so that casing pipe is absolutely critical here too. It provides that same essential tunnel, making sure both the pipeline below and the tracks up top stay safe and secure.
Okay, so our pipeline has successfully navigated all the stuff we've built. But what happens when it runs into a natural obstacle? Something like a river.
Right, you can't just lay a pipe on the riverbed. I mean, it could get battered by currents, smashed by debris, or messed up by shifting sand. And building a whole bridge just for the pipe, that's not always practical. So how in the world do you get from one side to the other safely and securely? Well, the solution is just this really elegant design. Instead of trying to go over the river, they go under it. The pipe is bent downwards on one side to travel deep beneath the riverbed, and then it bends back up on the other side. This really graceful dip is called a sag bend. By burying the pipeline way down, safely below the river's lowest point, it's totally protected from anything going on in the water above. It is a perfect example of engineering that works with the landscape instead of trying to fight against it. So, we've seen the big picture solutions for crossing roads and rivers, but the safety of a pipeline really comes down to the tiniest details. Let's zoom in now and look at how the pipe is supported and protected along every single inch of its journey. This is fantastic. Okay, on the left, we're seeing micro-level support. This is what's happening inside the casing pipe. Those are sack supports, and they're placed carefully to keep the carrier pipe right in the center. Then on the right, we see the macro-level support. The whole trench is lined with a soft bed of rock-free soil or sand to just cradle the pipe. It's protection from the inside out. So let's just recap these layers of protection because they're all important. First, you've got the bedding, which gives it a soft cushion. Then, the centering supports make sure the pipe never actually touches the outer casing. The materials for those supports are specifically chosen so they don't scratch the pipe's anti-corrosion coating. And finally, engineers make sure there's a safe distance from any other underground utilities. It's a whole system of interlocking protections. Now that we've seen all the individual safety measures, let's pull back to the big picture again and see how engineers plan for a pipeline that could stretch for hundreds and hundreds of miles. Exactly. You can't just guess how far apart to put these things. If they're too far apart, the pipe could sag under its own weight and break. But if they're too close together, it's just inefficient and super expensive. So, how do they find that sweet spot? They use tables, just like this one. Now, don't worry about memorizing the numbers here, just try to get the logic. This table tells an engineer the maximum safe distance, or span, that you can have between supports. So, for a standard 4-inch pipe, that's about 7.9 meters. But for a much tougher, more rigid 24-inch pipe, that distance can stretch to over 14 meters. It's all a precise guide based on physics and material science. And this right here, this reveals the crucial trade-off that engineers are always dealing with. Look at the table again. An 8-inch extra strong pipe can span just a little bit further than a standard one. So if you use that stronger, more expensive pipe, it means you need fewer supports, which could save money on installation. It's this constant balancing act between material cost, safety, and overall efficiency. So from protective casings under our roads to sag bends deep below rivers, and all of it governed by these precise calculations, there is just a brilliant world of engineering at work, totally out of sight. It's an invisible system that every single one of us depends on, every single day. It really makes you think, doesn't it? The next time you're driving down the road, just take a second to think about the incredible journey that's happening right underneath your wheels. What other hidden feats of engineering are out there, powering our lives without us even realizing it? Thanks for tuning in.